Okay, it's been a while since I made a video, and I thought this was a cute thing. So this guy's tweeting about um, the direction that Java is going. You have a old school Java example. It's not even that old school, right? It's post 1.5. You have actual generic collections, and I remember this because when the year I started programming was the year that this came out, and I bought a new edition of a Java book that was sort of treating all this stuff. But anyway, so he says Java 23 is looking suspiciously like Scala from 2 decades ago. Jokes aside, I'm glad that Java is evolving. Makes the transition to truly modern languages like Scala even smoother. Kind of a goofy, honestly, tweet. Like, oh, Scala is a great language, but I don't know. So and what he's talking about is Scala really was ahead of its time in terms of let me just make sure we're yeah in terms of its emphasis on, well, I think value classes, right? Like data is data. Not everything's an object, right? So just by having case classes, even though they fit nicely into the OO paradigm, right? They are classes. You really don't use them like classes. You're not supposed to extend them. They really are about data, right? I mean, it's as close as you can get to a struct. The amazing thing about case classes in Scala too is that they provided a value-based implementation of equality, which was just a member-wise equality over each of their members. A hash code implementation that did the same, so you could really just put them in collections and work with them like data in this really, really neat way. And then also pattern matching and some streaming APIs. So we see here and lambdas and closures, right? So people.stream, people.filter.map to list. You do this. This is a little bit more rusty, actually, how you explicitly make the iterator and then collect it. In Scala, we just typically call filter and map straight on the sequence, and we just create and throw away copies of the whole sequence. It's not really as efficient, but it's just what's idiomatic, and you just leave it to the GC to clean it all up. I mean, this is nice, right? List.of, arrays.aslist, like, I don't know, is this var args? Versus this thing is actually not var args, it's an overload, the list.of. Yeah, and then we, a for each, which is, super table stakes, but still. And then some pattern matching, right? Case person, and then you have string name and age. It's interesting you have to repeat the types. Maybe you're allowed to change up the ordering, I'm not sure. And then we have not string interpolation, but just string concatenation, which is okay in this case since there's only one thing being mixed in there. And, a couple of if guards, call these if Boolean guards, right? And I thought, it'd be cute to write this up in K1 and just see how this stupid little program turns out. So that's what I'm going to do. I'll try and leave this over here. Yep. And I've cheated a little. I've given myself a filter. This is kind of neat though. So I don't have this in the standard library yet, a filter on list, because the way it's implemented now, it will always do dynamic dispatch. What I want to do is sort of have some sort of a hidden type parameter be here and actually specialize the function on F such that we're doing static dispatch. Because unless that's true, you really don't want to be encouraging people to use higher order functions like map and filter as like the commonplace way of doing things if they have that much runtime overhead, right? So until they are free of overhead, which they will be once I do this sort of specialization of closures the way Rust does it, honestly. Then once there's zero cost, I'm going to gladly put these in. But what I am able to do is I'm able to extend list from here. I'm able to extend the namespace just by redeclaring it. And then I can add a method to list as if it were there just by declaring a function that takes a list of t. And so we have filter, and we'll go ahead and write map. And this should come out pretty nicely, and that's going to have to be to a u. So we need a type u, and this will be a list of u, and we'll do for I in self yield f of it. Actually, we can just say for self yield f of it. So there's your map. I didn't plan that. That actually just works out pretty nicely. And let's return hello, and we'll see that we're returning the wrong type. We need to return a string. So one thing that I want to highlight as we do this is the compiler speed. So we'll do a release build, make sure we're on a release build here. Before I do this, and then we'll have the LSP going, and we'll be getting that instant feedback, but I just thought we might as well here, just as a bit of an update. Compiler, check, compare. Okay, Java compare. And once macOS decides this isn't a virus, we'll run it again. And you know, we're actually parsing and type checking the entire standard library as well as our program. And you know, sort of the entire deal is taking I don't know how many, about 10 is that 10 milliseconds for the whole run? Hyperfine. Yeah. Well, it's fast, okay? That's the point. This needs to be an int, and we'll return 0. And let's do, instead of a check, we'll do a build, which is going to be a lot slower. We'll go ahead and run it. We'll say, hello, silly example. Stop timing it. That's checking. Okay. Yeah, that's fine. All right. So we have record person. I actually don't have to define this yet. Let's just make our people. Okay, so this is going to be let people. And I think we're already winning when we can just crack open a list literal here. And let's just put some structs in it. So this will be name and age. And there's going to be 4 of them. Bob, Charlie, and David. Okay, and let's print and we'll just do concat for now. Get 1, get 3. And David, name David. Okay. All right, so those are our people, and we're going to process them. So we'll have people filter, and we'll do p. And syntax here is really light. We don't even need an arrow. The cost for not needing an arrow is that the arguments must be enclosed in a pair of parens. But now I can just say p dot name Bob. Okay. Okay. And unfortunately, this doesn't infer yet, just because I don't think I've bothered to thread it through. So this is something I'm going to fix after this. But for now, let's go ahead and define a type. So this is just going to be an alias for the struct with a name and an age int, and we're going to call it person. So if we say p is a person, we're good to go there. And let's say we have count people. Yeah, we have 1 people, so filter worked. We'll do this style of programming, right? And now we're gonna map p. I don't have a 2 uppercase on my string, so we're just going to say we're gonna substring 1, something like that. So we'll chop off the first character. Oh, it doesn't look like I can parse that. Is that true? Yeah, that's true. So my, yeah, it doesn't want white space between the dots. So that's something to fix for sure. It looks like I've never actually tried to break things off across lines like that. But I can do it this way. Maybe we'll just make it smaller for a minute. I could have sworn that I did this. Anyway, this is our process people. And we need to go for p in processed people. Do. And then person info p, which seems to be just a function that returns a string. So fun person info, and there's a better way to do this, which we'll do in a second. P person, and it looks like we switch p, and this is dumb pattern matching. This doesn't make sense. Like, this is not the example I would write for pattern matching. I would actually match off something in the shape right now, just like predicates on an int, where I could just as easily if else on the age. But here we are. So we have name age if age is less than 20, and the syntax is actually really close here. And I would have yeah, name is a teenager. Let's grab another one, and if we're less than 40, name is an adult. Otherwise, we'll go name is older. All right. And I think it is middle-aged. Yeah, whatever. Okay. So we're just returning the name here in our map, which is pretty neat. So we have a nice compiler error here. Expected a struct with 2 fields, but got 1. So we don't just get expected person. It actually knows that person is a struct. It's kind of, we're pretty thoroughly structurally typed, especially since this is an alias. So this is really a structural type. If I had left this off, then it would really be more of a nominal type. So it's an alias, and we map, and yeah, this is true. So what I actually want to do is name is this, and page still. And does that work? It does. And now this is no longer red. And looks like we aborted. Maybe because I'm going off the end. I don't know. Let's just try. Let's just go with p.name. So, full disclosure that I did try this out. So I did use filter, but I did not use a map. Let me try. Slightly different. We're gonna do a for in, or do a for yield, which is kind of one way of mapping. It's how we implemented map here. We'll do the for yield directly. Let's see what we get. Yeah, Bob is an adult. So something goes wrong when we map. Which I'll need to look into. What we were getting was signal 11, which is some sort of illegal access. Nothing good. Nothing benign. So yes, we'll do it this way. I don't know. And there's our silly program. What's nice about it is it's, well, okay, we got our entire standard library. Define I64 main. But the point here is that we're about so that's about 200 essentially assembly instructions of code here. Extremely fast and lightweight. And we have a similar level of expressiveness to our little Java example here, but obviously like paying a lot less of the runtime cost, or the the runtime cost. We're not running on a VM. The compiler's really fast, so I just thought this would be a fun little thing to write up, see how it turned out. Got 2 bugs to fix, right? I have whatever's going on with map here, and then the little parser thing where I think I know why I don't want spaces here, because this should parse as something different from this, but I think I might need to distinguish between new lines and other white space for the first time. Anyway, thanks for watching.